So you should, I'll emphasize this yet again, you should only use the comparison test when there is something unusual, like a sine, a cosine, an inverse tan, and e to the 1 over n, or so on. This fella here, would you agree that sine squared x, the worst, the biggest it's ever going to be is 1, right? So this is guaranteed to be less than that guy, which means he's less than 2 over n squared. Are we comfortable with that? 2 over n squared is our comparison series, right? The guy that we're going to look at. When I look at this guy, I hope you see a p series and that p equals 2 and that is greater than 1, so it converges. And that's how simple a comparison test could be. Do you see, it's really, there's virtually nothing to do. Would you agree? It's pretty much that is less than this. This guy converges. If you're less than somebody that converges, you converge. You agree? Now, let me do same question, but a diverger. Let's suppose it was that one. Now, I can look at that and I know it's going to behave like a 1 over n. And that tells me everything I need. I need this guy. Right? Would you agree that this, oops, that's an n on the bottom. Would you agree that this guy is bigger than 1 over n? Would you agree sine squared n is somewhere between 0 and 1? So won't 1 plus sine squared over n be bigger than 1 over n? Agreed? Now, that's a p series, right? P equals 1. That's less than or equal to 1, that diverges. So if your guy is bigger than somebody that diverges, you diverge. If your original guy is less than somebody that converges, you converge. Now, in the big scheme of things, that's a lot less work, isn't it, than the limit comparison test. But you can't take n squared plus 2n over n cubed plus 5n and do this comparison, because it's not always clear that you're less than or greater than the guy you're writing down. So you may make a mistake on which direction it goes, or you may make a mistake in saying that it's definitely less than something when it's truly not less than it. Are we good with the comparison test? We don't do anywhere as much work on those. Right. Now, there are some examples I haven't covered, but they're in there in your homework and they take you through it. And it's basically, okay, I know it converges. What does it converge to? And what you do there is you just find S10, and that's your estimate. So on to our new guy then. 11.5. I'm only going to do the first part, which is the alternating series. And let's talk about what an alternating series is, and then we'll talk about the alternating series test. An alternating series looks like this. It alternates between a plus and a minus. Pretty good name, would you agree? Alternating, kind of tells you what it does. Now, when you see an alternating series, the most likely way you're going to see it written will be that. You could see it written like that. They all have one feature in common. Do you know they all have a negative 1 to the power of somebody? If you see a series that has a negative 1 to the power of somebody, either n, you could do n minus 2 if you wanted to, right? You could do any kind of combination. That's the two most common ones. You know it's an alternating series. So far, so good. Now, what does the alternating series test do? Well, it tells you whether an alternating series converges or not, which is what all tests do, right? And so here is the alternating series test. I'm going to call AST for short. Suppose you have an alternating series, and we'll call it that guy. Right, so the generic one of them, doesn't matter, right? That's what an alternating series looks like, right? If the limit as n tends to infinity of an is equal to 0 and an is decreasing, then the alternating series will converge. So if you want to prove that an alternating series is converging, you have to prove two things. You have to prove that the limit of this, right? Forget about that now, just this bit. And this, so in this case, it would be 1 over n squared. In this case, it would be 1 over n cubed plus 1. You need to prove that it's equal to 0, right? And you need to prove that this sequence is decreasing. That's important, the second part. If those two things are true, then it will converge. If, however, the limit as n tends to infinity of an is equal to L, where L is not 0. In other words, this thing converges to a half, a quarter, 42, right? If that is true, then the series, this guy, diverges. So don't we have a nice clean-cut test? If it has a limit of 0 and it's decreasing, that's the second part. If it has a limit of 0 and it's decreasing, the thing converges. If the limit isn't 0, right? So if the limit of the term is 4 or 44, it diverges. Looking good? So let's try some guys out, see what we get. Let's do this one. Well, in this case, isn't an that guy? Because that's the guy we're interested in, right? An is the 1 over n squared. Now, a lot of this is hopefully quite trivial, at least this piece is. Would you agree that this fella can be done with brute force and is clearly 0, right? I didn't need to do any heavy duty lifting for that one. Isn't that kind of, oh, yeah, it's 0. It's so easy, it's almost hard to say, how do I prove it? But I mean, isn't it brute force is how you prove it? Now, the second bit's going to be a little bit trickier. I think calling the function f of n instead of an will help a little bit. So this guy is 1 over n squared, which I am going to call n to the negative 2. And I'm going to differentiate it. So it's multiplied by the power and reduce the power by 1, and then make it look pretty. Isn't that exactly what you do in the integral test? What needs to be true then to prove that this is decreasing? What needs to be true about the derivative for this to be decreasing?
It has to be negative.
Okay, so I just need to prove that this is negative. And don't I only need to prove that it's negative for n positive numbers, right? 1, 2, 3, 4. And you don't even need to start at 1. You can start at 5 and it's still okay. So here's my proof. Would you agree that -2 is always negative? I just put little circles around it to mean, you know, the whole thing's negative. And would you agree that n cubed is always positive as long as n is 1, 2, 3, 4, 5? And what does a negative divided by a positive get me? Doesn't it get me a negative answer? And isn't negative just our way of saying less than 0? So it is decreasing. Well, that's it. We know the answer. The limit is 0 and it's decreasing. So this guy converges. Pretty cool. Limit is 0 and it's decreasing. Therefore, it converges. Don't need to do any more. Try one a little bit hard. N equals 1 to infinity. -1 to, say, the n plus 1. That guy. I need to prove that n over e to the n has a limit of 0 and that that is decreasing. If I can prove those two things, doesn't this make this converge? Let's see if we can do that. The limit as n tends to infinity of that guy. Now I got to prove it. Maybe you won't be able to prove it in your, well, you should always prove it, even if you don't write it down in your homework. It's good practice. What method will I use to prove that this limit is 0? And I can't use brute force. It doesn't work. Okay. And in L'Hopital's world, you differentiate the top and the bottom. And now I can do brute force. And yeah, the limit is 0. By the way, that is the way that that question should be written if you wanted to make your life easy. This is probably how it will be written. So if you see the question like that, will you immediately turn it into this before you do any of your work? It's just going to make your life a lot easier in the long run, right? Now, I'm only halfway towards proving this. Is it the second part of the deal? I need to now show that it is decreasing, which means I'm going to have to differentiate the function. So here is the guy. If I write it like that, won't I use the quotient rule? If I decide to write it in this form, won't I use the product rule? Do you see, both are going to get to the same answer. What do you want? Do you want me to do it as a quotient rule and prove that it's negative, or find a derivative using the product rule and show that it's negative? I don't want to do both, but which one do you want me to do?
Quotient rule.
Quotient rule, right. So on the quotient rule, you call the top guy F, you call the bottom guy G, and the derivative using the quotient rule is F dash G take away F of G dashed all over G squared. And let's see what that gets. If you differentiate the top, you get 1. You leave the bottom alone, you get that. Take away, you leave the top alone, you differentiate e to the n, you get that. And you take e to the n and you square it. Well, that guy and that guy, I can pull out an e to the n, and it leaves me with that. E to the n squared, I could call that e to the 2n. I can cancel or partially cancel that, and I get 1 minus n over e to the n. So far, so good? Now, If n is a nice number, right, a positive number, won't e to the n always be a positive answer? E squared, e cubed, e to the 50th. Won't we 1 minus n be negative when n is 2, 3, and 52? And a negative divided by a positive gives me a negative. That makes it less than 0, so that makes it decreasing, doesn't it? If the derivative is negative, it's decreasing, which means then we have our conclusion. It has a limit of 0 and it's decreasing, which makes you converge. Agreed? Let's try one that diverges then. Just to be different, I'll do it that way. Now I'm going to prove that this is a diverging alternating series. The limit as n tends to infinity of that guy. The answer is going to be 1. Agreed, you can tell by looking. How do you think you could prove it to me? Because proof is more important than the answer. What method could I use to prove that the limit is 1?
Divide both the numerator and the denominator by n squared.
Agreed. And if you don't like that, can you do L'Hopital? Both work. So that's going to be the limit as n tends to infinity of 1 over 1 plus 1 over n squared. You then do the brute force part. I tend to write a lot more lines than you probably end up writing. And that is 1. And doesn't that correspond to, where's my little sentence? Have I thrown it away? Ah, here it is. If the limit isn't 0, in this case it's 1. Conclusion is that that series diverges. Do you like this test? Does it have a nice flow to it? As long as you know how to differentiate and find limits, won't you get an answer one way or the other? Converge or diverge. In fact, when you diverge, don't you have less work to do? See, the minute I found that, I don't care if it decreases. I don't care if it increases. Won't it matter? No. Doesn't that kill it? Stone dead. The minute that's a number, it diverges. So don't do anything else. Why bother? It's not going to change anything. I'm getting good vibes off this one. Does this one feel cleaner than the comparison test, which is kind of, you turn it into something else. I'm not quite sure what you turn it into sometimes. This one's got a much cleaner feel to it. So some of the other ones are good. Would you agree the geometric series test is pretty clean? P series test is. Integral test, in my opinion, is the worst test of them all. It takes forever and a day if you're going to do the integral test properly, doesn't it? There's a lot of stuff, and sometimes the integrals can be really ugly, you know, chain, whatever, integration by parts. So let's start right at the beginning again, because sometimes the ones at the start are harder than the ones that come later. We're being asked, does this converge or does this diverge? Since you've got 5 guesses, you will get it right eventually, but let's do it properly, right? How you should do it in a test. I know it's alternating. It might be -1 to the n, it might be -1 to the n plus 1. Let's fix that first. When n is 1, it's a positive answer. When n is 2, it's a negative answer. When n is 3, it's back to being positive. When n is 4, it's negative, and so on. will -1 to the power of n, or will -1 to the power of n plus 1? That's your choices. -1 to the n or -1 to the n plus 1. Which one will generate this plus minus pattern?
-1 to the power of n plus 1.
Agreed. Let's check it out. Right, the fourth number is negative, agreed? Just randomly picking one. Isn't -1 to the power of 5 negative? And the third one is positive. Isn't -1 to the power of 4 positive, right? So if you want to figure out which one it is, just pick one of them at random. And if -1 to the n doesn't work, I bet you -1 to the n plus 1 will, right? It's only two choices, you're going to get it. Now, 1 gets you 2/3, that gets you 2/5, the fourth one gets you 2/9, the last one gets you 2/11. Everybody in the top is 2. How do I make 3, 5, 7, 9, 11 work? I need a formula with n's in it to go here.
Plus 2n.
I hear 2n, which I like. You have to tweak 2n a little bit, don't you?
1 plus 1.
Agreed.
Right.
You agree on that? 2n plus 1. Now, if you're wondering where the 2n come, it's quite common that you add the same number to go along. Say you add 2, add 2, add 2, add 2. That doesn't tend to, that will be 2n. Right? If you add 3, add 3, add 3, add 3, that will be 3n, right? That's the first color. Now, if you're lucky, 2n will work, but more than likely you'll have to tweak it. So all I do is I pick one, 3. 3 should give me 7. Well, 2 lots of 3 only give me 6. Do you see why I need the extra 1 to give me 7? Right? 3 should get me 7. 2 lots of 3 needs an extra 1 to do that. And if you make it work for one of them, it will work for all of them. So there's the guy. So the first stage is, let's find the limit, and hopefully the limit is 0. Would you agree that's just basically brute force? It's almost like, yeah, it's almost trivial. Agree? Really quick, that one. And now f of n is going to be 2 over 2n plus 1. I would strongly suggest that you write it like that. It's just going to make the differentiation easier. So we'll differentiate it, multiply by the power, reduce the power by 1, and do what else? Because it is a chain rule, isn't it? So I finish with times 1.
Times 2.
Times 2. Now, if that was 2n squared, wouldn't I do times 4n, right, and so on? But I'll make it look pretty. -4, and the style points make it look like the original. See how style points can help you, right? Isn't that much easier to work with than some weird looking thing with negative powers in it? Now, -4 is always negative. Would you agree that 2n plus 1 squared is always positive? And our classic negative positive combination means that the answer is negative, which means it's less than 0, so it's decreasing. And if it is limit of 0 and decreasing, we can now say that this converges, I guess to be formal, by the alternating series test, because that's the test I just used. Get a good flow to it. Of course, if you can't make this happen, you won't be able to, keep the flow going. So hopefully you're good at that, or get practice at it. I'm not going to do this question except the bit where we write down the formula. So this is a version of question 2. Oops, a minus. Okay. -1 to the n or -1 to the n plus 1. Which one of those generates a negative and then a positive, then a negative again, and then a positive? Which one does that? -1 to the n or the n plus 1?
Yes, Dan.
Agreed? Are you all just basically picking the first one and saying what does it work? If it works, use it. If you need to change it, don't you just call it n plus 1 and that'll work? Now we got a fraction going on. 1 gets you this guy, right? N equals 2 gets you that fraction. There's n equals 3 and finally 4. We are looking for patterns. We are looking for a formula for the top and a different formula for the bottom. So I guess I'll hide the top, hide the bottom, I should say. All right. 2, 4, 6, 8. I need a formula for making that happen.
2n.
Agreed. While I'm at that, can you pretend the series started at 4/5? Because sometimes they do that. Do you notice that it's still add 2 on the top? So it's still going to be 2n. But how will you tweak it? If the series was that was the first number and then it continued. 2n wouldn't do it. By the way,
2n plus 2, right?
yeah, 2n plus 2. Wouldn't you? The first one you'd need to double it up. And I wish I hadn't drawn that down because it's distracting us. Right, what about the bottom?
N plus 3 times -1 to the power of n.
Right, so we got the whole thing. We don't need the -1 to the power of n because we're just focusing on the numbers themselves.
Oh, and you already wrote it
yeah,
down.
this guy
Missed that,
here
sorry.
is already doing that, right? Are we comfortable with this guy? I'm not, as I say, I'm not doing that, but I know the answer. Does anybody else know the answer to this question before you even do the working? Does it converge or diverge? I can tell.
Diverge.
Diverge.
Right. Can you see the limit's going to be 2 and that kills it? So that one would be a very quick question because there's only one more step to do and you're done. That's pretty straightforward, don't need that. Find something a little bit different. Yeah, it's pretty straightforward. Pretty straightforward. This one is similar to question 8. Okay. Let's find out what happens when the limit tends to infinity. The only bit that you forget about, right, is the -1 part, right? Because what that does, isn't that the guy that makes the pluses and minus halves? So to that guy, I guess they could have stuck it there. I would have probably stuck it there, but they stuck it over here. I'm not even going to look at that guy yet, because if I did, the chances are I'd make a mess. Don't you sometimes have to write things in a better form to understand what the limit is? Now, the way I've written it right now, isn't it pretty clear what the limit's going to be when you do brute force? Because you're just going to say 2 over e to the infinity, 2 over infinity, 0. If I tried brute force on this guy, and some of you, it might not be a problem, but for others, wouldn't that be quite hard to understand what it's equal to? And isn't there a possibility you might think the answer's infinite? So just a little tester. Right, now, the function that we are going to be checking that it's decreasing, I think that is actually a good way to write it. If I wrote it as 2 over e to the n, wouldn't differentiation be a little bit ugly because you might want to do a quotient rule? And it would work if you did the quotient rule correctly, but a lot of people forget that the derivative of 2 is 0, and it's more work than it needs. Because the way this fella is written, don't you just get that as the derivative, right? And now I'm going to write it like that. And we can say the top is negative all the time. And isn't e to the power of n a positive number for 1, 2, 3? And that gets us the whole thing is negative. That gets us that it's less than 0. And so we are looking at something that is decreasing. And so the conclusion is, whoops, is that because the limit is 0 and it's decreasing, then we can now say it converges by the alternating series test. So what you see in that piece of paper is what I would expect to see in a test. If I say to you, is this converging or not, right? You would show me it. And it's helpful, if I'm in a good mood, I'll probably ignore the fact, but it's kind of helpful if you tell me which test. Because aren't we coming to the point now where there's an awful lot of tests, and it would be nice that you say, I'm using the alternating series test, or I'm using the geometric series test, or the limit comparison test, right? Or the P series test. God, we do have a lot of tests, even right now, don't we? We still get 2 more to go, ratio test and end through test, but at least we're getting towards the end of them. So do you feel comfortable that if I gave you something that looked like this, you could convert it into that and then test? Or if you're just given one, you can do the test. You feel comfortable with that?
I have a question.
Yes, Art.
So for number 8 you just did, are we supposed to ignore the 2 times -1 to the nth power and just do?
Oh, yeah, when you do the test, if I'm picking you up, Alec, you ignore that. That's what you said. Yes. And the answer is yes, you ignore that.
All right, thank you.
Right. The alternating series test is always going to have this, right? So these 2 guys are all you need to check for convergence. So let's suppose, well, not suppose, let's say we have a series that converges, right? So you're going to trust me because I'm going to tell you it's true. That one converges. Can you trust me that if you check it and you do all the stuff, it converges? Wouldn't it be nice if we could find some way of estimating what it converges to? Right? Well, here we go. If you use Sn to estimate a series, so estimate, I guess its full title would be an alternating series. Then the error Rn, right? Remember that Rn you did with the integral test, the remainder? The error Rn is equal to En plus 1. Let's show you how that works. I know that converges, and I'm going to do S of 4 to estimate it. So what's that going to be? If you plug in 1, you get negative. So it's going to be -1 squared, that's a half. Then you're going to add 2 squared, so you're going to add a 5th. Then you're taking away 3 squared, a 10th. And then you're going to add 4 squared is a 16th, so 17th. Are you comfortable? That's what S4 would be, right? The first 4 terms added up. Now I'm going to do that in my calculator because these are decimals anyway. So -0.5, add a 0.2, take away a 0.1, and add Well, I can't do that one, so I add 117. And I get the answer, negative 0.341176. I'm going to start writing and some stuff. R4, the error, is basically the value of A5. So that's going to be 1 over 5 squared plus 1. That's 1 over 26. And that's far too much accuracy, so I'm going to round these answers off. 1 divided by 26 is roughly 0.04. So S4 is negative 0.34, give or take 0.04. So in this story, the answer is going to lie somewhere between negative 0.38 and negative 0.30. Do you see we already have a good idea of where it adds up to? It's around about negative 0.3 something. Would you agree? Now, isn't that a much easier way of finding the error? Because it's just the next term that you didn't use. Technically speaking, you only need to add one to that because that's the lowest it's ever going to be in the art. But, you know, plus or minus to keep people happy. Cool. Right. Suppose I did this guy, remember? And it's bugging me the way they're writing it. So I'm going to write it the way I would have written it. Yeah, right. Doesn't that just look more natural that way, right? Right. Let's suppose we did S3 to estimate it. We know it converges, we've already done that. So you plug in 1, you get negative 2 e to the negative 1 plus 2 e to the negative 2. Take away 2 e to the negative 3, right? That's what S3 is. And then I have to go to my calculator and do that. So negative 2 times e to the power of negative 1, add 2 times e to the power of negative 2, oops, almost got it wrong there, subtract 2 times e to the power of negative 3. And the answer for our estimate to what that equals is negative 0. Seem to be a lot of negatives here. 565 to 3 decimal places. Now, the error when you use S3 is A4, right? The next number up. And the next number up is 2 times e to the negative 4. So 2 times e to the power of negative 4. And the answer I get to 3 decimal places is 0.037. So this fella is negative 0.565, give or take 0.037. So what would that look like? Negative 0.565, take that away. And that gets me negative 0.602. And then if I take the same guy, and I add 0.037, I get negative 0.528. So can you see in this case, that converges. And wouldn't you agree, it probably converges somewhere around about negative 0.5 something, right? Pretty good. So the last, have we got time? Yeah, we do. The last type of question that you could be asked would be, how many terms do I need to add so that the error is good to 4 decimal places? You know, that kind of question. How many terms would I need to use for SN so that the estimate I got was correct to 4 decimal places. So I'm going to choose an easier one to work with. Now, we want the remainder to be 4 decimal places. When you want the remainder to be correct to 4 decimal places, don't you have to make it equal that number? Does that make sense? Because when you round off to 4, isn't it the next digit that makes the difference if it's 5 or above? And I need to now solve this question or this equation. Why is that an n plus 1 and not an n squared? Isn't Rn the next number, an plus 1? This guy here is what an is. Can you see what an plus 1 would be? Is that? That's the reason. So that makes sense why I'm using n plus 1 now. Now, I want to solve that. If you can, you should try and do it algebraically. Sometimes this expression is so ugly, in which case you just use your calculator. But in this case, I think I can get away with it. Would you agree that n plus 1 squared is just the reciprocal of this guy? And that I can do in my calculator. 1 divided by 0.00005 ends up being 20,000. So won't n plus 1 be the square root of 20,000, positive, because we know it's a positive answer. And I am looking at n plus 1 equals 141.4. And that makes n 140.4. And I'm glad to tell you that WebAssign does exactly what I wanted it to do. What number do we round this off to? In other words, how many terms would we need? Is it 140 or is it 141?
141.
Remember the rule, always round up to be safe. So if I wanted to get what does this series add up to, and I wanted it to be correct to 4 decimal places, wouldn't I need to add up 141 terms? And I could tell you whatever that adds up to, that is the correct answer for this series to 4 decimal places. You wouldn't do that by hand, wouldn't you? You'd find some computer way of doing that because it's too much work. There's something elegant about alternating series. I don't know what it is. I just like them. I mean, they're just kind of smooth. They don't throw too many curveballs, you know, weird integrations that you have to fight your way through. I mean, isn't finding limits relatively straightforward as long as it's not ugly? Isn't differentiation something you've done for ages now, so we're pretty cool at that? The bit about proving it's negative, isn't it just take the top and the bottom and figure out what it is? Most of the time it's obvious it's plus or minus, and they're done. Well, put your, oh, we should finish with a joke. And before we finish with a joke, 2 things. One is a joke, the other is some information. But say your last name for attendance while I get my brain organized. So your last name for attendance. And now I'll tell you the thing and then I'll finish with the joke. Monday is a holiday. I won't be here, neither should you be. Homework has been extended to midnight Monday, so you can choose to wait till then. And so is online test 2 being extended to Monday. So you've got a little bit more extra time. It will be available at 2 p.m. today if you are, you know, if for some reason you want to get it over with, but it probably won't be most of you, but it is there. Right, and the joke then. Why does Waldo, you remember Waldo? Why does Waldo always wear stripes.
Why?
Because he doesn't want to be spotted.
Oh, that's like a serious dad joke.
That is a serious dad joke. You're right.
I had to hear it twice.
Oh, poor David. No, you didn't. I didn't tell you that joke. Well, you would have heard it a couple of times, but I didn't tell you during statistics. So you weren't.
You told me that one before.
Oh, I have, yes. I'm sure if you've had me before, you probably hear most of my jokes. Occasionally, I tell one that I haven't said before. Were you the one that went and told us, how do you tell a dad joke?
I don't think so.
No, it's a parent.
Okay, that one's from last semester.
Okay, you're out of here. Have a nice break, everyone. I will hang about for any questions. Otherwise, see you Tuesday.
Have a good weekend.
Thank you. Have a good weekend.
You too. Bye-bye, guys.
Professor, I had one question about 11.4.
Okay, you got it handy? What is it? What's the question? I'll write it down. Unless it's a long one.
No, it's hold on one second. Someone 1 plus sine n over e to the n.
1 plus the sine of n.
Oh, sine of n's on top.
Okay, so sine of n is on top, and
Plus
on the
1.
bottom, oh, plus 1. And e to the n is on the bottom. Agreed?
Yes.
Right. So what am I going to do with this one is a comparison test. There's a sign in it. It's a comparison test, right?
Yeah.
So, would you agree that the biggest value sine n is ever going to be is 1?
Yeah.
So this is going to be less than or equal to 2 over e to the n. So far, so good?
Yeah.
I'm going to rewrite this as 2 times 1 over e to the n. And then I'm going to write it as 2, 1 over e to the power of n. Do you see a geometric series now? So I'm comparing it not to a p series, but to a geometric series. What is the common ratio r for this geometric series?
1 over e.
And would you agree 1 over e is definitely less than 1? Because 1 over 2.7 is less than 1. And does it not make it converge? And that makes this guy converge by the comparison test. Because isn't this guy less than a guy who converges?
Okay. No, the whole, yeah, I was struggling with what to do with the e to the n.
Right. Most of these ones have n squared in the bottom, so don't you just end up with 2 over n squared, and that's a p series. They're easier to recognize because you do them so much, but you know, occasionally a geometric pops in. Off the top of my head then, an example of that might be that guy.
Same thing.
Same thing.
Okay. All right.
Okay,
Thanks, Professor.
no problem. Any other questions, guys?
I was wondering on that question.
This one? Yeah.
Does it matter like if I put like a 50 on instead of a 2 on the right side?
What, you put a 50?
Yeah, like can you interchange variables like that? Or?
I don't think I caught what you said at the top. You said, is it okay to put a 50 where that 2 is? Is that what you said?
Yeah, like any like large number to make it.
Yeah, to make it sure. Yeah, sometimes you have to make it a little bit bigger to be sure. So it's 50 can work. If you want to make it smaller, can't you make it a half? If you want to make the direction change from being less than to be bigger than, you make the top number a bit smaller, and that can cope with it as well.
Yeah, I was wondering like how to manipulate it if that was like allowed. So that makes things a lot easier now.
Right. So you just pick a big number that you know is safely bigger, 20. If I wanted to show something less than, wouldn't I turn that into a 1? I'd make something less than 2. And if I did that, then wouldn't it be true the other way around? You could say that that is now bigger than that, right? Because you know, sometimes you want to prove you're bigger than somebody, and sometimes you want to prove you're less than somebody, right? If you know it's going to converge, don't you want to prove it's less? If you know it's going to diverge, don't you want to prove it's more?
Yeah, that makes sense. It's like the bigger series converges, the smaller one has to converge, and then
And the reverse of that, the other direction.
I also had one more question. Right,
Sure.
2 more questions, but
Okay, keep going.
1 divided by ln of n. That is number 7.
Is that an alternating series one?
No, this is on 11.4 again.
Okay, has it got a sigma around it, I'm assuming?
It has sigma to 2.
Yeah, they did the 2, so it won't be 0. And your question was, what does that look like? I mean, what would that would be a comparison test because it's got a log in it. So here we go.
Okay. I was just thinking of like the squeeze theorem or something, since it's kind of like a P series almost.
Well, yeah, the squeeze theorem is something you typically would only be using if you were trying to find the limit of something. It doesn't really play well for series because even if the limit was 0, couldn't you have a series whose limit was 0, but the series was still infinite? You know, like sigma 1 over n, for instance. Now, what I would do here is I recognize that this is bigger than that. And you can check it out. Smaller number makes bigger fraction. So won't this be bigger than that? And isn't this a diverger? And you're bigger than a diverger, so it diverges.
So you are allowed to use n for like that's similar to ln.
Yeah, I mean, if the guy in the bottom is not a guy you can use, you can replace him by something that you know is always bigger or smaller, depending on what you're trying to prove. And so log n, I would do that one. Yeah. If someone gave me a 1 over e to the 1 over n, I'm just making this up because I can't think of some, that guy there, right, e to the 1 over n, isn't really that big. So you would be able to say that would be true as well. So that would diverge as well. You typically want to make this guy here a P series, or like the other one, less common, but occasionally it happens, a geometric series. So the guy on the right-hand side has to be like a 1 over n cubed, 1 over n squared, 2 over n cubed, right? That kind of looked at, or less likely, a geometric series as we have here.
And there was just one last one. Sorry.
No, you're good. I like these. Do you mind if I keep these on the video? Because that way people can go and look and pick up some things that I didn't cover.
Yeah, that's totally fine.
Okay, so what you got for your last one?
The last one is 19. It's 2 divided by n to the power of 1 plus 1 divided by n.
Ooh, okay. So I have this guy. And I'm going to say that this guy is bigger than that guy, so he diverges.
Divergent. So you
Technically, a 1, but you would just call it n.
I think that's it.
Right. Have you noticed that the comparison test, the hard part is sometimes figuring out what to make it bigger than or less than. Once you've done that, the answer's kind of obvious.
That clears up a lot of my questions. Last night I was like, wait, what do I do here?
And so in this case, I think and I like the fact you're asking, because you just don't want to say, well, I tried one, so I know it's the other, but you actually want to know why it's the right one. I don't like the fact that WebAssign just says, 2 circles. You either pick the one that says converge or you pick the one that picks diverge. Because if you're not a good student, won't you just pick the wrong answer and say, okay, I've got 5 guesses, it's the other one. 10 seconds of your life and you move on, and you've really learned nothing. And especially if you see a test question, I don't care what the right answer is. I honestly probably won't even pay much attention to it. I'll be paying attention to what you do to prove it. Like, for instance, a classic one's the integral test. There's a lot of work in proving to me that using the integral test that something converges or diverges, right? There's just tons of work. Not a circle on converge and walk away and think you've done something mathematical. You've just guessed. That's all you've done when you do that.
I feel like if I kind of cheat myself, I'm gonna test or something. I'm just gonna be like, oh, what do I do?
Yeah, that's what will happen, and that'll come through. I bet you when we do the midterm test and people come to do these questions, the ones who've taken shortcuts that they shouldn't have are going to come a cropper. That they're going to say, okay, and you won't get a 2-circle pick a dot. That's not the way the midterm's going to work. Midterm will be prove that this converges or diverges, and if I don't see proof, you get nothing. Because you haven't proved anything if you don't show me proof. And so you've got to know the method and how you set it down. And that's my little get off my pictures box. Any more questions? Anybody else?
That's it for me. Thank you so much.
You're welcome. See you on Tuesday. Maggie, would you got anything?
Yeah, I did. I actually had 3 questions.
Go for it. Which is yours?
All right, so I had one, n equals 1 to infinity of 1 over n to the 4th plus 8.
Okay. I would do a limit comparison test on that. What would you compare it to?
All right, so I compared it to 1 over n to the 4th.
Perfect. That's exactly what you should have done. So let's move on to the next stage then. So our BN, right, our comparison guy is that, and we'll assume you've done the work to do that, the surgery. So we're going to be looking at this fella. So it's going to be the limit as n tends to infinity of that fella on top. Chloe, get out of there. She's went underneath the table again, Maggie. Sorry, Willie. Come on. I don't want you getting electrocuted. Come on. You know better. Come on, Chloe. Let's go. Come on. Come on, girl. Oh, God, she's got herself all hooked up with the cables now. Come. You little. How did you do that? Let me get that off your neck. Come here. Come on. You know, it's like you tell her not to do something, so she thinks this is exciting to go underneath the table where all the cables are. She worries me sometimes. She's going to kill herself. Right. AN over BN. The algebra of dealing with this is simply to leave the top unchanged and then multiply by the reciprocal. And this guy, how's that? Right. Would you agree the answer is going to be 1? Can you tell by looking that it's going to be 1? But how are you going to prove to me it's 1?
Would you divide by the n to the 4th term?
That's how I would do it. And if you do that, you get the limit as n tends to 1 of 1 over 1 plus 8 over n to the 4, and then you can brute force it. 1 plus 8 over infinity squared, 1 over 1 plus 0, which is 1, which is good, because according to the limit comparison test, if the limit of this ratio is a number that's not 0, right, as long as it's a number, then it behaves the same way as this guy. What does that guy behave like? Well, it's a p-series, right?
Right.
And it's bigger than 1, so this guy converges. So by the limit comparison test, so does this guy converge.
Okay.
What was it you weren't sure about in that question? Was it?
Well, I'm not sure what I did, but I got my answer for the limit part was that it diverges, and it was very confusing to me because I got the p-series part.
Yeah.
And
did something go wrong with the algebra? Maybe you lost the 1 and you had a 4 in the wrong place, or an n to the 4 in the wrong place.
I think that's probably what happened. It had to have been because I did the rest of the working right.
Okay. The good news is that if you did the rest of the working correct, you would still get partial credit because you're doing the right process.
Okay, that's
And
good.
you would have got the wrong conclusion, but that was only because somewhere the limit went wrong, right? You did a part of the puzzle wrong in the limits, but you were doing it the right way, which is the process. Right.
Okay.
You said you get some more.
Yeah.
I wonder
first-
if, yeah, I wonder if the mistake is the same kind of mistake that you've been doing each time, and so it's just one mistake that you haven't fixed yet.
Oh, it might be. I don't know.
But let's
up
do the next one anyway. What is the next one
Okay.
going to be?
Number 13. It looks like I finished it
Mhm.
and I got it right.
Okay. Then there might not be a question there.
No, there's not a question there. But the next one,
Mhm.
it was 14. It was the limit is n equals 1 to infinity.
Oh, and we'll do the series. I'll put it here. So n equals 1 to infinity, and what was the series look like?
It was n plus 1 divided by n to the third plus n.
Okay. When you did the comparison guy, did you get eventually 1 over n squared?
Yes.
So you know that's a p series, p equals 2, which is bigger than 1. So we know our guy is going to converge. Our guy means this one. So all we need to do now is prove it by finding the limit as n tends to infinity of the original divided by bn, which is this guy. And so you have the original multiplied by the reciprocal. And then what I'm going to do is multiply them together. Yeah. So what have I got? I've got an n cubed plus n over an n cubed plus n. Do you see that guy?
Yes.
And won't the limit be 1?
Yes, it will
So
be
what-
1.
You weren't getting 1 again, were you? Or were you?
No, and I see my mistake is when I was doing the limit, I somehow manipulated my denominator into n plus 1 instead of n cubed plus n.
And it should be n cubed plus n squared, actually. Now that I look at it, but yeah. That doesn't change the result, it's still 1. So top guy untouched, reciprocal at the bottom. That's the trick. Then multiply them all together. And once you've got that, you can use L'Hopital or divide top and bottom by n cubed, whichever method you prefer.
Okay.
Is the mistake you made in this one similar to the one you made in the earlier question? Is it? Does it look like it may be happening at the same spot?
It could have been. I don't know.
Okay, just so that if you have chance, have a look again and say, yeah, I'm maybe not doing this piece of the algebra quite right, and that's why I'm, getting it wrong. Because it sounds like you're doing the start perfect, and that you're setting it up correctly. So it's somewhere here downwards that something went astray.
Okay.
Okay, you said you get I think you said one more, but whatever. How many? Doesn't matter. What you got next?
All right, so on 12, and this is just a verbal question. You don't have to do the working, but I got, so it was n equals 1 to infinity of 1 divided by n raised to the nth.
Ooh, interesting.
So I compared it to 1 over n squared because we did that part in class.
Yeah, that would work.
And then I got, it's a p series, p equals 2, which is greater than 1, so it converges. And
Correct.
then I stopped there because I didn't know if I needed to do the limit, and I didn't know how I would do the limit.
That particular question would work as a comparison test. It will also work as a ratio. So the limit as n tends to infinity would be the original divided by that guy, right? And that's going to be the limit as n tends to infinity of that guy times that guy. And then this algebra might catch you a little bit, but it's that cancels partly with that, and you take 2 away from it, you get that. And I can do brute force here, because what you're basically doing is 1 over infinity to the power of infinity, which is 1 over real infinity, which gets you, 0. Okay, then rewind that. That is not going to be done using the limit comparison test, because shouldn't that be a number that's not 0? So wind back. Isn't that guy less than or isn't that guy less than or equal to that guy? And so the comparison test says you converge.
Okay.
So that was a comparison test that was dead easy. But I didn't notice until I got to the end that the limit comparison test wasn't any good. As long as you get a number, you're good. But zeros, yeah, 0 means don't use it. You know, try something else.
Okay. So then with all of the comparison tests, is that what you called them?
Yeah.
Where you just compare and oh well, then it's gonna converge just by
Or
looking at it.
diverge.
Or
Well,
diverge.
you find, yeah, you prove that it's less than a guy that converges, or you show me it's bigger than a guy that diverges. If you can do that, is the original less than a converger, or is the original bigger than something that diverges? So if you can prove that, then that's pretty much the comparison test over.
Okay, so then that would be all the working required for a test.
Right. Yeah, so yeah, the comparison test has, well, you'd have a little bit about this guy being a p-series, and that p equals 2, and that's bigger than 1, and that's why you know it converges, right? You'd have that little piece to say why you said it converged, right?
Right.
Because it might have been 1 over n that you used, in which case you'd be telling me it diverges, right? So it depends on what you compare it against.
Okay.
That guy, that guy, that guy, running short of guys I don't know. E to the 1 over n guys. Anything that's got a weird thing to it, comparison test. If they only have n cubed, n squared, square root of n's, that kind of stuff, or 2 to the n, 5 to the n, that kind of stuff, you can use the limit comparison test. It's when they have one of these weird guys that the comparison test has to be used, which is actually a lot quicker if you know how to do it.
Okay.
Can we use these as well, Maggie?
Oh yeah, I don't care.
We
Sorry,
good, right?
took me a minute there. Yeah.
Okay, then I will say bye-bye for the time being.
Alrighty.
I'm off to officer, so if something crops up, just join me there.
All right. Is the one we went over today, the last one that we did, that homework set, is that still included in the working?
The alternate, it's now being moved to next week. So
Okay.
that's due on the 23rd.
Okay, so it's not going to be on the test.
No, won't be in the test.
All right, wonderful.
It'll be in the next test, so you'll still get to see it.
Okay.
Okay,
All right, well, thank you. See you next
Cool.
week.
See you next week.